Welcome to this explainer. Today, we're taking a look at algebra. Actually, scratch that. We aren't just looking at algebra, we're treating it like a thrilling puzzle game. Think of it like a giant digital escape room, and our ultimate mission? Finding the hidden treasure, the unknown variable. Getting these puzzle-solving skills down early is absolutely crucial. Whether you're writing the back-end code for a new app, trying to predict trends in data science, or honestly just trying to balance a tricky real-world budget, the logic we're decoding today, it's the exact same engine running behind the scenes.
Okay, let's take a really quick look at our roadmap. We've got 5 levels to conquer today. First, the power of x. Second, the art of balancing. Third, conquering brackets and fractions. Fourth, mastering multi-step equations. And finally, number 5, the inequality plot twist.
So let's jump right into section 1, the power of x. Before we actually start playing, we need to know what kind of treasure we're hunting for, right? Well, the elegant simplicity of a linear equation is that it's really just a mathematical sentence with an unknown value. Usually that's an x, and it's raised to the highest power of 1. Look at this classic example. 2x plus 5 equals 15. It's a perfectly balanced scale. Something unknown multiplied by 2 plus 5 gives us 15. Our whole objective here is just to peel back the layers and figure out what that x is hiding.
But, equations aren't the only things we're going to run into. Before we officially kick off level 1, here's your visual cheat sheet for inequalities. Because sometimes, instead of an exact equal sign, we need to compare quantities. We use symbols like greater than, less than, or greater than or equal to. This is super cool because it lets us map out entire ranges of possible answers instead of just locking into one single value. It's kind of like saying the treasure is buried anywhere north of the old oak tree, rather than strictly beneath it.
All right, moving on to section 2, the art of balancing.
Let's see how this builds our absolutely most important core mechanic. Level 1 throws a wonderfully simple equation at us. X plus 7 equals 12. Now in this game, your golden rule, and I mean no matter what happens or how messy the board gets, is to isolate that variable at all costs. You just want x sitting all by itself on one side of the equal sign.
And this brilliantly illustrates our balanced scale analogy. Since our x currently has a plus 7 attached to it, we've got to do the exact opposite to get rid of it. So we subtract 7. But, and this is a big but, remember the scale. Whatever we do to one side of the equal sign, we have to identically do to the other to hack this code. So we subtract 7 from the 12 as well. Boom! The noise is completely cleared away. Our isolated variable stands alone. And just like that, the first level is effortlessly solved. X equals 5. You've literally just performed the foundational operation of all algebra.
Let's turn it up a notch with section 3, conquering brackets and fractions.
Now that we've got the basic mechanics down, the game is going to start throwing some obstacles our way. But don't sweat it. We have the specific tools to smash right through them. Here's a slightly more intimidating one. We have an equation where our precious x is trapped inside a set of brackets, guarded by a multiplier on the outside. 3 times the quantity x plus 4 equals 21. Looks tricky, right? But there is a very clear key to this lock. By using the distributive property, where a times the quantity b plus c equals ab plus ac, we can just expand those brackets first. We multiply the 3 by the x and the 3 by the 4. Suddenly, we're looking at 3x plus 12 equals 21. And from there, we're right back to basics. Subtract 12 from both sides to get 3x equals 9, and then divide both sides by 3. We are systematically dismantling the trap piece by piece.
And once again, we successfully hacked the sequence. The hidden value reveals itself to be 3. The bracket obstacle is officially cleared.
Next up on the board is the fraction trap. I know. For a lot of people, fractions look like the scariest part of math. But honestly, it's really just another annoying obstacle that we can easily clear out of the way. Take a look. X divided by 2 plus 3 equals 7. Just like before, we start by moving the easy peasies. We subtract 3 from both sides, which leaves us with x over 2 equals 4. Now, to break the fraction, we just do the exact opposite of division. We multiply both sides by 2. Whether it's a simple equation like this one or a harder one with complex denominators where you'd need to find the lowest common multiple, clearing those fractions out of your way first by multiplying, that is your ultimate power move.
So the crucial takeaway here is that by staying calm, relying on your basic rules, and systematically reversing the operation step by step, you are always going to win the level. X equals 8, we've beaten fractions, and we are absolutely ready for a bigger challenge.
Welcome to Section 4, Mastering Multi-Step Equations.
All right, consider this the boss fight. Here, variables aren't just neatly sitting on one side, they are scattered across the board, and we have to wrangle them together. Check this out. 5x minus 7 equals 3x plus 9. This looks completely chaotic compared to level 1, doesn't it? We've got x's on the left, x's on the right, numbers everywhere. But take a breath. Our core mission hasn't changed one bit. We just need to round up those variables and isolate them.
We treat the variables just like regular numbers. We want to move all our x variables to one side, so let's subtract 3x from both sides. At the exact same time, let's move our regular numbers over to the opposite side by adding 7 to both sides. And suddenly that whole messy equation transforms into 2x equals 16. We literally just took a complex multi-step boss and shrunk it right back down into a basic friendly level 1 problem. Divide by 2 and we are golden.
And just like that, the multi-step equation is totally solved. X equals 8. I love this because it brilliantly proves that no math problem is too big or too intimidating if you just break it down into small, logical steps.
And finally, Section 5, the inequality plot twist.
Just when you thought you had fully mastered all the rules of the game, we're going to introduce a new mechanic that subtly changes the landscape. Remember those inequality symbols from earlier? Well, here's the good news. Solving inequalities works exactly the same as balancing normal equations. If x plus 4 equals 10 gives you x equals 6, well, then x plus 4 is less than 10 gives you x is less than 6. The logic perfectly mirrors itself. That is, until you stumble into the danger zone, the negative multiplier.
Consider this your massive visual warning label. Seriously, burn this into your memory. When you are working with an inequality and you have to multiply or divide both sides by a negative number to isolate your x, you absolutely must execute the plot twist. You have to reverse the inequality sign. Greater than flips to less than flips to greater than.
Let's slow down for a second and see this in action. If we have negative 2x is greater than 8, our first instinct is to divide by negative 2, right? And that's correct. But because we divided by a negative, we have to flip that greater than sign around to a less than sign. So the result is x is strictly less than negative 4. And if we were mapping this treasure hunt visually on a number line, we'd mark negative 4 with an open circle because it's strictly less than, not equal to, and draw an arrow pointing all the way down into the negative numbers.
And there you have it. You've officially leveled up from basic balancing all the way to handling multi-step bosses and those tricky inequality plot twists. The beauty of these foundations is that they are entirely universal. So my question to you to wrap up this explainer is this. With these incredible puzzle-solving mechanics now completely mastered, how are you going to use the power of algebra to balance your own budget, write your next piece of code, or hack the complex variables in your own life? The treasure is out there, and now you have the map. Thanks so much for joining me.